All right, so we previously talked about the components of blood and the different parts and how they're important to, they have important functions. Now we're going to talk about the greater system that this blood floats around in and how it interacts with the rest of the body. So the first thing to talk about is how blood gets transported. And blood is transported through the blood vessels. What are the two names for the types of blood vessels that we have in our body? Arteries and veins. Really great. Yeah, so arteries and veins. So that's really what we're talking about today, and how these structures operate and what they're made out of and all that sort of thing. So arteries are there to carry blood away from the heart. And this is really important. They carry blood away from the heart. It has nothing to do with oxygenated versus deoxygenated blood. It's all about moving away from the heart. Happens that a large amount of our arteries are carrying oxygenated blood, but we're going to talk about that in a second. Okay. The larger arteries may have many branches, and the smaller branches are then called the arterioles. Arterioles, probably it. There we go. Arterioles. The aorta is the largest artery. So the aorta comes right off of the heart, and then that aorta slowly gets branched away, branching first into smaller arteries, and eventually into arterioles. So we're talking about coming from the heart. We can see these larger arteries in red here. This one running up the throat. There's another one. Okay, you're gone too. There's a larger one down here, running down the center column here, and then running out over into the legs. You can get especially like a baby, you can measure the pulse in the inside of the leg, and that's because there's a very thick artery down there. Also, why getting damage to the leg, someone can bleed out, and that's because the artery is damaged. So the larger arteries are the ones that are the most fragile, the ones that are the most dangerous to get damaged. Getting a cut to the neck, you can, that's a very dangerous place to get cut, or in the inside of the leg. There's also large arteries that go down the arms, and then they branch out into the arterioles. So the aorta has a diameter is 25 millimeters. So diameter that's around, right? That's pretty thick. And the arterioles are only about 0.2 millimeters, so it's about 100 times thicker, the aorta, right, than the arterioles. Arteries have thick, strong, muscular walls because they're under high pressure, and because of the force at which the heart pumps. They are under high pressure because of the force at which the heart pumps the blood. So in this system that we're going to be talking about, the heart is going to be pumping. That pumping of the heart pushes the blood through the body. So, of course, immediately just adjacent to the heart, we have to have the largest arteries to manage the most blood. And then those arteries become smaller and smaller as they move farther away from the heart. So maybe we should put a little note here. The large. They have to be a little bit more centralized. So there's also another really large artery up in the bicep. There's these larger arteries that funnel the larger organs. I'm just going to rethink about some of these things. Let's go to something like... That's not high, it's thigh. I think let's pull up a quick picture here of human circulatory. So let's just look here. So you can see the thickness of the arteries and how they get narrower as they stretch away from the body. So this is just the arteries and veins. You can see that they're very wide coming off the heart, and then they slowly taper down as they get closer and closer to the extremities. Again, down here, these would also be tapered out and get narrower as they go away. Notice also that usually when an artery is getting narrower, there's also a narrow vein nearby. And that is important, as we'll talk about when we get to the capillary system, how these are actually always connected to one another. Large ones go to the lungs. Why would you need large arteries and veins to be going to the lungs? What are the lungs there for?
Transportation.
Transportation, oxygen, yes, very good. Good, just always keep thinking. Where we also have the kidneys here. Kidneys are for filtering blood, just like the liver. And so we also see a system of arteries and veins that are stretching into those kidneys there as well. Spreading all the way down, we can see the large artery that comes down through the thigh. That's the femoral artery. Really, really dangerous to damage that femoral artery. So be careful. All right. There, for most major organs, you'll find a major artery, including the brain. We have major renal veins, renal arteries, gonadal veins and arteries, brachial, axis, cephalic. All right, lots of work there. Okay, so the artery walls have 3 layers to them. They have an endothelium. Endo is usually a word we use for inside. So endo here, this is this endo part. You'll see this appear in other courses in bio as well as chemistry. We use endo sometimes. So endo is a prefix meaning inside. So endothelium, this is the inside layer. Where we have these very tightly packed cells. Then we have a middle layer where the smooth muscle fibers are. These muscle fibers are there to regulate blood pressure. So the muscle fibers have a natural tendency to contract or relax. And so using these middle fibers, these middle layer muscle fibers, we can constrict and relax the arteries, which controls the flow of blood to different areas of the body. And then we have finally an outer layer that is a tough connective tissue, and it has some nerves and tiny blood vessels that will nourish the artery walls. So as much as the artery is carrying blood, it actually needs its own blood supply for the tissues that surround it as well. So that blood supply comes in on the outside. Any questions about that? Okay, great. So once the arterioles get smaller and smaller and smaller, at some point they become what we call capillaries. And capillaries are really, really essential to the blood system. At the point where we are capillary sized, they are now about the opening is now about the size of a single cell. It's actually slightly smaller than a red blood cell in size. And so these openings here, about a little bit smaller than a red blood cell. So the red blood cells, remember, they were floppy. We talked about how that sort of donut shape allows them to bend. They actually have to bend to slide through the capillaries. But in this spot where the capillaries are, the walls of the capillaries themselves are also super thin. And at this point, there's an ease of gas exchange. So the oxygen molecules that were on those red blood cells can easily be diffused through the capillary walls and feed whatever tissue is underneath. So capillaries typically will coat important tissues, and by pumping the blood through these capillaries, you allow for a chance for oxygen and gases to be exchanged. So this is where gas exchange occurs, is in the capillaries. They do not always look like this. This is a very simplified image of the capillary system. So, but they do coat essentially everything. The lungs themselves are actually heavily filled with capillaries. The capillaries, in this case, coat a part of the cell, a part of the lung tissue. And so we can see all the red and blues here. The blue is the veins, and the red is the arteries. They're extending. What would be filling in the space between these red and blues is all capillaries. And those capillaries there's plenty of capillaries here, of course, because it's where all the gas exchange is happening. So you need your lungs to be fairly capillary full, because that's how the gas can exchange. So capillaries make a network of blood vessels and have a single layer of endothelial cells, so that's a single layer of tissue cells. And their diameter is only about 0.007 millimeters, so really small. This is a little less than a cell wide. So this is slightly smaller than a RBC. So slightly smaller than a red blood cell. So the red blood cells are squeezed through. This encourages contact between the red blood cell and the capillary wall. If you didn't make contact between the red blood cell and the capillary wall, the chance for diffusion of gases between the red blood cell and the tissues around it would be reduced. This is another place where sickle cell anemia is dangerous because in sickle cell anemia, the capillaries are so small that, and the sickle cells are slightly smaller yet, that the sickle cells can actually jam into a capillary and they can form a clot in that capillary. Additionally, because the capillary and the capillary and the sickle cell are not perfectly matched, like in a healthy red blood cell, we don't get that same pressure between the red blood cell sliding through the capillary, and so the amount of oxygen exchange is going to be reduced still. So most cells of the body are only a cell or two away from a capillary. So this is probably one of the reasons it's difficult to draw. You have to kind of think that every single cell in your body is not more than one cell away from a capillary. So capillaries really permeate everything. All of your tissues are, either coated in capillaries, or they are the capillaries actually go right through them, like in the kidneys. The exchange of materials only occurs across the surface of capillaries, not through arteries or veins. So this is also really important. So the exchange of materials only occurs through the surface of capillaries. So here is a capillary cross-section right below. This one actually looks like it's a little bit wider than a couple of hearts of red blood cells, but that's okay. And so the red blood cells are transporting through, and you can see that these types of cells are obviously red blood cells. They've even colored them red. But they're squeezing through. All of this around, this section around, this is all some sort of tissue, right? So this is a tissue that this capillary is passing through, and right here, I'm going to change pens here. So between these red blood cells and the capillaries, we are exchanging O2 going out, CO2 coming in. So oxygen is going out to the cells around the capillary, and CO2 is coming into the cells. Or probably into the plasma. Also, any sugars that you're carrying around, or any other molecules, amino acids, all of those products that you were carrying in the plasma, those are all being transported at this point when you're in the capillary to the tissues around it. There's a couple of years ago we had the bodies exhibit here, and this year we've gotten the boy, I want to see this picture. There's a picture in my mind of the human circulatory system bodies exhibit. Yeah, this is the one. So so in the bodies exhibit, they what they do is they use a polymer, and they inject the polymer into the heart into the heart and through the circulatory system, and this polymer solidifies. And if you then take away all of the human body aspect, or take away all the other tissues, you dissolve them essentially, you're left with this. So this kind of gives you a better idea of where blood is transporting and how it's kind of transporting. You can see clusters where, as it clusters together, these are where capillaries are. And you can actually see, remember this is only veins and this is only arteries and capillaries, right? And you can actually see the organs. That's the important thing. So one of the most important things that your circulatory system is doing is it's providing oxygen to your organs. If you don't provide oxygen to the organs die. Every tissue in your body needs oxygen, particularly the ones that are doing something important, right? So we can see locations where you have high circulatory circulation, like in the fingertips. These ones you can actually push the blood out of your fingertips by yourself if you want. You can see them move, see the color go away. You also can see it in the right around the stomach and the small intestines and those areas. Those are where lots of absorption is happening. So they, of course, are also coated in capillaries. And the lungs themselves, remember, they've removed all of the lung tissue here. There's no more lung tissue. All that's left is the blood and the circulatory system. So this is not, when we get into lungs, probably next week, there's no brachia, no trachea there, there's no alveoles. All we have are the capillaries. That's all that's left. And yet you can see the entire lung. And that's of course because the lung is just these big sacs of capillaries. They're just full of capillaries, as well as the other structure that's there to catch oxygen. And then your face and your head is just full of blood. That's anybody who knows that if anybody's ever gotten a small cut on your face, you know that it bleeds for a really long time. You've got lots and lots of blood. There's lots of interesting muscles, right, that need to move and control your appearance. And then you also have your brain, which needs lots and lots of blood to survive as well. Brain is consuming tons of calories every day, and part of being able to consume calories means that you will need oxygen to do that. Yeah. And there's lots of examples where they've done this sort of thing. Here you can even see, in this one you can even see you can see the lips and face, even though it's just the blood vessels That's where I've seen them. Okay. Chicago has a great museum, by the way, so if you ever get a chance, it's not that far a drive. Okay. So once the blood has reached the capillaries, it will start its travel back towards the heart, and so the capillaries are sort of the middle point, and now the blood is heading back towards the heart, and so the veins are what are going to be responsible for that. As capillaries collect together, they form venules, which lead to the veins. The blood in the arteries has a high pressure, but that pressure is lost in the capillaries. The veins actually only have 1/10 of the pressure that the heart does, that the arteries do. They're similar structures as the arteries, but the middle muscle layer is thinner. Much lower blood pressure. Typically, if you're donating blood, they're going to use a vein to donate blood from. If they're going to inject you with something with like a medicine, or they're going to give you an intravenous like the little baggie, like they're getting water or something at the or a saline solution at the hospital, then that's also all going to go through the vein. The blood in the arteries is too high pressure that it would actually spurt out, or it would be pumping out of your body too fast to be safe, or couldn't be stopped well enough if they wanted to donate blood from your arteries. So instead, they get your blood donation through your veins, and the blood coming out of those veins is much lower pressure. Also, the veins are pumping, the blood in the veins is going straight to the heart. So if you're getting medicine through it, so maybe you're getting an injection of some sort, a treatment for whatever, when they give it to you intravenously, because this way the medicine will travel straight to the heart, and then from the heart it will be dispersed through the rest of the body. If you were getting insulin injections, you'd also do that into the vein. You do the insulin into the vein pumps it to the heart, then the heart disperses it around the whole body. If you put the insulin into an artery, it would just go towards wherever that blood was going. So if you put it in an artery right here, it's probably going to your fingertip first, then it has to go through you know, a capillary system, it might just be absorbed by those fingertips. It would be a waste of that insulin, right? It would just be it would be really targeting one specific area. In addition to being hard to actually inject in because the artery would be pumping back on it. So veins have a low resistance to flow of blood back from the tissue. Have low resistance to the flow of blood back from tissues. The fluid pressure from tissues is the force that returns the blood to the heart. And many of our larger veins have one-way valves that stop them. So throughout the larger veins, even the ones that you donate blood with, they will have these sort of little flaps on the inside. They work as valves. So as the blood gets pushed through, then even if there's a lull in the pressure and the blood tries to move backwards, it actually ends up automatically closing the flap. And I know that I've donated blood once or twice, and they said, "Ooh, I hit a valve," and it's usually bad. That usually means they have to redo the donation. They have to move the needle somewhere else. And I feel like there's at least one vein I have in my arm that like has lots of valves, and they almost always hit a valve, and it's really painful. And they have to move it and put it somewhere else. So, yeah. I'll just talk here. So we can think about this as, kind of think about it like, in a way the heart is sort of pumping up a balloon, right? So you can think of the capillaries and the organ and its ability to hold blood. That's kind of the balloon. So the arteries keep blowing blood into the organ or the balloon. It gets full of blood, and then that blood has to go somewhere, and the only place to go is into the veins. So this creates what is known as the organ blood pressure. So the organs fill with blood every time that the heart pumps. The heart pumps blood forward. That blood it gets pushed into the capillaries. The capillaries fill up those tissues. Those tissues can only hold so much blood, and so then that blood gets pushed forward into the veins, and then the veins trap it because they have these valves. So the next time the heart pumps, it pushes more blood through, and then even when there's a break between pumps, because we know that our heart has to refill, during that break, the blood will try to flow backwards, but it gets trapped by these valves. So then you pump again, push more blood in, and then there's a stop, and the valves will prevent it from flowing backwards. So one of the things that we do is that as we walk around, we actually, our movement actually pushes blood around. And so if we are too sedentary in our lives, we can actually end up pooling blood, especially if your veins and arteries are not in good condition. And just moving, this is one of those things that they're really on everybody should go for a 15-minute walk every day or something. That's part of that is because as you walk around, you push your blood around your body simply by moving. And that's the veins themselves don't have very strong muscles, so it's actually the movement of your body and the movement of your limbs that can actually give that blood a little bit of motion. Think about if anybody's ever worked with a hose. I know at the end of the year I need to pack my hose away, and the hose has no pressure, no water pressure in it, right? But as soon as I start picking up the hose and moving it, water starts pouring out of the hose. So even though the veins don't have any, the muscles in the veins isn't very strong, it can't build very much pressure, as soon as you start moving your limbs around, you're moving those veins, you're compressing the veins and relaxing the veins. And so just by doing this, sometimes when your hands feel like they've gone to sleep, you start pumping your hands. What you're doing is you're really just pumping water. You're pumping blood through those veins. and you're encouraging the arteries to pump more blood to those organs. And we do that when we're cold, right? One of the things that blood transports is heat. So when you get cold, you start to shiver. That's your body forcing your body to move. Because if it forces movement, it forces the motion of blood away from the heart to those organs and bringing the heat with them. Because most of your heat is generated in the chest. If you sit for a very long time, you can sometimes form varicose veins. These are veins that have actual turns and bends in them from not being worked enough. There's probably other factors involved as well. And then sometimes really dangerous pooling will appear as swelling in your feet. Particularly feet are more susceptible because we tend to move our hands a little bit more regularly, but your hands, you can also get swelling in the hands as well. Having low blood pressure will increase the effects of both of those, or they'll increase the chance of both of those symptoms. So being anemic or having other factors that affect blood pressure, anemia is not necessarily directly related to blood pressure, but having factors that affect blood pressure will also play into these dangers.
I'm just curious that what happens when you have varicose veins?
So the varicose veins, they are sort of, they end up being these deformed veins. I don't know that much about it, but I definitely will look up a little bit more about it for you tomorrow.
People have like those crazy veins in their calves, for example.
Yeah, it's certainly something that can develop over time. As far as I understand, it seems to be related to sort of a sedentary lifestyle and other factors that would affect weakening the vein walls. Circulation issues, yeah. I meant to look into it before I started talking about it, but I will. I'll make a note for myself to make sure to see if I can find some more information about that. As I certainly was looking at it and be like, I'm really interested in that. I should find something else for that. Okay. So just to look at at them side by side, we can see here is your central lumen. So here's the central the one cell thick layer on the inside, the endothelium. This endothelium then is covered in a thick, smooth muscle layer. The veins also have this muscle layer, but notice that it's much smaller and it's much thinner. And by being thinner, the vein has less structure to it. It's not as strong. Also, because you don't have as high blood pressure in here, the veins can actually collapse on themselves a little bit easier, and they can be restrained. Very hard to squeeze an artery off, but much easier to squeeze the veins and stop the flow of blood that way. And then we have the fibrous outer connective tissue layer. This allows it to connect to the rest of the body and be directed, and also where blood can flow and provide nutrients for those muscles or oxygen. Here's your capillary. The capillary, you lose all of those outer parts. And you can imagine that as these are getting thinner and thinner and thinner, that we are shrinking on the inside as well as shrinking the muscles and connective tissue layer is not going to shrink. So the arterioles and the venules, they'll also have probably less muscle and also less diameter. I believe you have this little table to fill in. This is an empty table, yeah. So we can fill this in as we go. At the end there, so arteries, they take blood away from the heart. Veins take blood to the heart. Arteries are deeper in the body, so this is another interesting thing, is that we often associate blue blood with veins and red blood with arteries. What actually is occurring there is that veins tend to be near the surface of the skin, and your skin stops light that is colored in the reds and low energy colors like red and orange and yellow. They tend to bounce a little bit more off of your skin, whereas the blue light can travel down and then bounce off of the veins. So blue light tends to travel through the skin and bounce back, and that's what you're seeing when you see blue light for your veins. You're actually seeing the light traveling through the skin. There are no valves in the arteries. The arteries have high blood pressure, so that just pushes the blood straight through. Whereas in the veins, the blood pressure is much lower, so the valves capture the or stop the blood from flowing backwards. Thick muscle walls, thin muscle walls in the veins, very high blood pressure, low blood pressure, and then there's a pulse in your arteries. That's where we're detecting the pulse. So anytime that you are detecting pulse, you're actually feeling the artery moving, not the vein. All right, thanks everybody for attending, and we'll see you tomorrow. Have yourselves a great day. Hello? Hello? I think my dad is butt calling.
Can I get the exam? The test?
What test?
Oh,
your test back.
Yeah. Because the last Thursday and Friday I wasn't here.
Right.
I got my teeth going up to me.
Yeah, how'd that go?
It was too much hurt.
No? Okay. There you go. Wally, you still there? You can pick this up. Morning. How are you? Alright, let's go. Ernie?
Yeah.
Alright. Yeah, this is the right place. Come on in. Grab a spot anywhere you like. Go straight from one to the other.